Welcome. Today's lesson is over ratios. Before we do that, let's look at our number routine for today. So in a number routine is that how do you know that 2.5 times 3/4 has to equal 1 7/8 and 2.5 divided by 3/4 equals 3 1/3? How do you know that? Well, first of all, why is it when you multiply 2.5 times 3/4? Why is the answer less than the original quantity of 2.5? Because when you multiply by a number that's less than one whole, the original quantity will decrease. And why is this one, the answer is greater than what you started with? Because you're finding how many groups of 3/4 go into 2.5. That is one reason why. So let's see why. So first of all, we are multiplying and dividing fractions, not mixed numbers, fractions. Do you know how to turn 2.5 into an improper fraction? 5/2. So in multiplying, you multiply the numerators, you multiply the denominators. How many eights go into 15? One whole. You have 7 left over. 1 and 7/8. Again, if you do not know how I came up with that, let me divide this and show you. How many groups of 8 go in 15? One time. You have 7 left over. 1 and 7/8. So let's look at our division. Do you know how to turn this division into a multiplication question? Because when you're dividing 3/4, you're really multiplying by the reciprocal of 4/3. So 5 times 4 is 20. 2 times 3 is 6. Let's simplify this. What can I divide the numerator and denominator by? Well, they're even. I'm going to divide both numbers by 2, so it's 10/3. And how many 3's going to 10? 3, which is 9, and 1 left over, 3 1/3. So we just had a test on this. Hopefully, you did not found difficulties in multiplying and dividing fractions. So what? So here's a picture. This is a picture of giraffes and zebras. What comparison does this picture show? Write down or think about what comparisons of the quantities you see in this picture. So I'll let you think about it. Alrighty. Discuss with your table any similarities or differences between the tribe mates. And we're going to share it as a whole class. Well, what I see is in this circle, I see there are 3 zebras and there are 5 giraffes. Or I can also see, I see there are 9 zebras out of 15 giraffes. Or some people may say, I see 3 zebras out of 1, 2, 3, 4, 5, 6, out of 8 total animals. Someone might have said, I see 5 giraffes out of 8 total animals. Or they may have said, I see 5 giraffes compared to 3 zebras. What you just did is you compared quantities, and that is called ratio. Ratio is comparing two quantities. So we are in the next activity. You are going to be given a card. So your card, for example, let me show you. Your card may say one red to 4 green. You are going to find another group that has an equivalent ratio of centimeter cubes. So as you walk around the classroom, there may be another group that has 2 reds to 8 greens. Are these equivalent? Well, let's think about it. 1 red to 4 green. Red, green, 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 green. While another group has 2 reds and 8 green. Are they equivalent? If I break this down into 2 groups, Is this equivalent to this? It is. Oh, so I could have simplified. I could cut this group in half in order to look like the first group. So how do you know that they are equivalent? Through simplifying or cutting the second group in half. Or here's the first group. I could multiply double the group. So I could double it to red, green, 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 green. So they are equivalent. Can you create another equivalent ratio to it? So let's see. What about red, green, 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 green? What about 3 red, 12 green? What about 5 red, 2, 4, 8, 12, 16, 20 green? Well, they all go back to original parent of 1 red to 4 green. If you simplify, it does. So ratio is, again, it's a comparison of two quantities. It can be comparing part to part or part to whole. So let's go back here. What is the ratio of zebras to giraffe? And here I see 3 zebras to 5 giraffes. If I look at these two groups, it could be 6 zebras to 10 giraffes. If I compare all 3 groups, it could be 9 zebras to 15 giraffes. What about zebras to the total animal? Zebras, there are 3 zebras, let me use a different pen color, to 8 animals. Oh, wait, let me show you a different way to write this ratio. 3 zebras to 8 total animals. If I compare 2 groups, it could be 6 zebras, 1, 2, 3, 4, 5, 6, to 16 animals. And if I compare all 3 groups, it could be 9 zebras to 24 total animals. So ratio is comparing two quantities. It can be written as part to part or part to whole. So you can compare the different parts to each other, or you can compare this part to the whole group. So we're going to practice this right now. Find the ratio of triangles to squares. Simplify the ratio if possible. So triangles to square. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 triangles to 3 squares. Ratio can be written in 3 ways. It could be written using 9 to 3. It could be written using a colon, but I prefer writing ratios in fraction form. Can I simplify this ratio if possible? I can. What can I divide the numerator and denominator by? By 3. So it's going to be 3, 1. So what does 3, 1 mean to you? It means there are 3 triangles for every 1 square. Find the ratio of circles to total shapes. There are 6 circles to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, to 18 total shapes. Can I write it in another way? 6 to 18 shapes. 6 colon 18. Can I simplify this if possible? What can I divide both numbers by? I could divide both numbers by 2, 3. What about 6? 1/3. That means there's 1 circle for every 3 total shapes. So another way you could do it is you can create a table if that is what easier for you. If there are 3 squares and 9 triangles, can you find equivalent ratios or equivalent fractions to it? 3, 6, 9, 18. How did I turn it from 3 to 6 and 9 to 18? I multiply by a scale factor of 2. Next one. How do I turn a 9 to a 27? Times 3 times 3, that would be 9. So there's 9 squares to 27 triangles. And how do I turn 3 squares to 12 squares times 4 times 4? That would be 36. So if I have 12 squares and 36 triangles, I can break it down and it'll be equivalent to saying 3 squares to 9 triangles. What about if I simplify this? Divide both by 3. So there's 1 square for every 3 triangle. Is that true? Let's look at it. 1 square for every 3 triangle, 1 square for every 3 triangle, 1 square for every 3 triangle. It is true. So what we're going to be doing is we're going to be having students get up. There'll be 3 boys and 6 girls standing in front of the room. What is the ratio of boys to girls in this group? Boys to girls. There are 3 boys to 6 girls. 3 colon 6 and 3 6. Could you simplify this if you needed to? Yes, I can. I can divide both numbers by 3, so that means it's 1/2. But what does 1/2 mean? There, for every 1 boy, there are 2 girls. So there are blank as many boys as girls. There is half as many boys as girls. So if you have 3 boys and 6 girls, part of my artwork, half as many boys as girls. What about if there are 3 boys and 6 girls? What's the ratio of girls to total student? There are 6 girls to a total students of 9. 6 colon 9, 6, 9. Could I simplify this? Yes, I can. I can divide both numbers by 3. You get 2/3. That means there are 2 girls for every 3 students. And the main thing I want to ask, does order matter? Does order matter? It does. Because, for example, if we were doing boys to girls, if you had done it 6-3 instead, that would have been a completely different answer. That means there would be 2 girls, 6-3. That means you have said there's 6 boys for every 3 girls. That would have been wrong. So make sure order does matter. So our last part of activity is you're going to be getting some candy and you're going to be doing some comparison on your own with zombies. So let's look at this last part. Can you complete this table? 4, 8. I think this is a 12. I think this is a 20. I think this is a 24. 6, 8. Simplify to 3, 4. 3, 6, 9, 12, 16. Wait, 3, 6, 9, 12. Oh, this is 15 and this is 18. So what is the relationship from 6, 8 to 3, 4? What's the relationship here? Some of you are going to say is divide by 2. I agree with that. But we're going to use the word scale factor. What's another way to say divide 2? When you're dividing something by 2, you're really cutting it in half. So what's the relationship between 3, 4 to 15, 20? What's the relationship from here to here? It is times 5. So make a prediction. If you have 21 purple, how many oranges? 3, 6, 9, 12, 15, 18, 21, 4, 8, 12, 16, 24, 28. There will be 28 orange pieces. How do you know? I linked it up the table. However, is there maybe a faster way of doing it? If I had 3 purple and 8 orange, how can I build it up to 21 purple? What scale factor should I use? Times 7. Oh, wait. This is wrong. So it's 3 purple for every 4 orange. If the scale factor is times 7, so 4 times 7 is 28. And that's how I could have got to it. So this is a study of ratio. Ratio is comparing 2 quantities, part to part or part to whole.